Okay, cool. So again, I'm Joel Griffith. I'm the founder, CEO of Browserless. Been an engineer for quite some time. Did a lot of headless automation in the past. Any library you can think of, Selenium, WebDriver, wrote my own even. And that was kind of how I got into Puppeteer. And then, decided that this was something that needed to have a better product, better support. So we started Browserless. That's kind of how Browserless began. That was 5 years ago. So it's been 5 years running Browserless. It's been awesome. Helped a lot of people, and just thought, we could really do a lot better job getting more information out there because we see people running into the same problems over and over again. So why not throw another webinar out there? So that's what we did. And so, yeah, today I wanted to kind of just go over 2 or 3 things that we've seen people commonly trip up on and speed improvements, and then do a little demo of something that we've been kind of working on that we think you might be interested in. So with that, I will get started and share my screen. Stuff I'm going to be showing you today is code. So if you're not an engineer or don't plan on being an engineer, I'm sorry. Hopefully this isn't a waste of time, but hopefully it works well for you. It looks like we're having internet issues. See if this gets working here. Okay. Seems like we're good. Okay, I'm going to keep going on. We will also record this and share it now too. So if we have hiccups here and there, I'm just going to keep going, and then we'll share the video too, because this is all be public information at some point. So no worries if things kind of have little hitches here and there. But anyways, yeah, so going to go over some code examples. Apologies if you've never written code, don't know how to write code. This isn't for you. I have 3 things I wanted to cover today, 3 topics. There's a topic on rejections, which are a tool that you should absolutely utilize if you're running something at high scale and scraping. There's a parallelization example. So we'll talk a little bit about how you can orchestrate workloads and try to get the most out of your CPU RAM utilization. And then we're going to talk about this 3rd thing that I think is really exciting. And I think it's the next genesis of how stuff is going to work in the future, and it's called hybrid. It also uses a to-be released product that we've been working on. So not quite out there just yet, but very exciting. And I think it's going to change how things are done potentially in the future. But I'm getting ahead of myself. So let's start with rejections. So very quickly, we're using Puppeteer Core. Playwright can work just as well with all of this. I'm going to be using some stuff in a minute that is Puppeteer only, but this is a great example for how to scale a little bit better when you're doing scraping or any kind of automation, really, to be honest. So pretty simple. Puppeteer Core library. I didn't want Chromium installed because we're using the service. So no need to bundle and install Chromium. So Puppeteer Core just comes with the library. It doesn't come with the binary with it, which is nice, faster, no download. So take note of that if you're running stuff in CI or whatever, and downloading Chromium is a chore, but you're using a service, just use Puppeteer Core because you don't have to worry about setting environment variables and all that. It'll just do the library. I have our token in our bash as a bash environment variable. So that's already been set. And this is just a nice way of moving your token away out of your code, so you're not having sensitive information in your code. Anyways, so I have a little script. We're going to connect to Browserless in the cloud, set up a new page. In the future, for today, for the first shot of this, we're just going to do a new page straight from the browser object. We're not going to do anything fancy. And we're going to see if we can load CNN. Sorry, CNN. I know you're a great site sometimes, but we're going to kind of use a punching bag because this site is just notoriously slow almost all the time. And I'd actually be surprised if it even responds without any interjection. So by default, Puppeteer puts a 30-second limit to load a page. So it took about 16 seconds. I'm actually surprised it came back. Usually that's not something that's, you know, what we see typically. So usually this times out. So yeah, this is just default standard Puppeteer stuff. We're going to do a page setup here. And this is what I was talking about with rejections. So instead of just doing a new page, we're going to do a new page, but we're going to do a little bit of setup work with it. And we're going to say any image, media, font, style sheets, don't load those because those just take up more time. Network requests in particular take up a lot of CPU time. So if you're struggling with CPU time or CPU saturation, take a look at this because this could actually help you a little bit. Hopefully now, this will actually help us out a little bit with the speed. If I could get control back in my computer, that'd be great. Okay, so we're going to try this again and see if this actually gets us a little bit of a performance boost. It should. And if it doesn't, that's okay. There's a third thing we'll demonstrate here in a minute that will help a little bit too. But this will just, again, help with CPU load. So it's something that we won't see performance-wise, but it'll be something that we see, you know, in CPU stats going forward because we're just not doing as many network calls. So it's not looking good. The demo gods are not with me today. So we hit the navigation timeout. But again, that's okay. Let's see if it's just a one-time thing, see if this fixes it a little bit. Usually this does come back quicker. But again, there's a lot of things going on here. We're running a headless browser, you know, it's making network calls. And anytime you make a network call, you know, you're going through the pipes of the internet. So it could be any number of things you hit. But anyways, this usually is a great cost savings in terms of just resource usage. So heavily recommend doing this. And it's probably going to time out again, but that's okay. Yeah, no worries there. We have another option here. This one usually does make a pretty big difference, especially on third-party sites, is this block ads parameter. Now, this is like a special thing inside of Browserless. Internally, we do a bunch of ad blocking with this when we see this parameter. So this just adds more to that network rejection. And anytime it's an ad domain, we just reject it. Usually this ends up saving quite a bit of time. Yeah, you know, we were at 15 seconds before, and now we're down to 7 seconds, so about half. So it's a pretty good cost savings in terms of, you know, resource and time when you mix these parameters. Obviously, it's not going to work for everything. Some third-party scripts that are going to get loaded, that page needs. So take it with a grain of salt. But block ads can be super helpful just because, again, it's probably something that you're not interested in if you're just getting like the page title or whatnot, or content in this case. Like ads are ephemeral. They don't really need to be around for that long. So yeah, that's the first one. Take a look at doing page request rejection. And again, here, this example will be online, but we're just rejecting images, media, font, style sheets, that sort of thing, just to kind of cut down network calls. And then the final thing was block ads. We did block ads just so we can cut down the amount of ad traffic. Again, more network calls, and it's a black box, really, depending. So that is the first one. I did see in chat that we had a question about why not JavaScript or Python. Well, this is JavaScript, so that's good. Node backend, JavaScript. It's not Java, if that's what the original question from Elias was. Python is something that we also are working on too a little bit. There is a Puppeteer module. This all has to do with headless Chrome and how to use headless Chrome scalably. So there's a great set of tools for Python, beautiful soup, lots of other things. This focuses on more doing scraping with the browser, whereas there's other libraries like, again, beautiful soup's a good one for Python. But there's even things like Cheerio for Node that just do old school curl calls, and then you parse content after the fact. This actually goes a step further and, you know, fires up a headless browser, does everything from a headless browser. It's not every case you're going to need this, but it'll help in those cases. Okay. So the next one, parallelization. So I have two functions here that kind of illustrate two different points. let's say we get a list of arrays or a list of websites here. So I have, example.com, which is usually fast to load, Yahoo, and Reddit. And I want to just get page content from these. You'll notice I'm not really doing anything with the content. I'm just using it as an example here to call it, because it does take some time. So most places or tools you'll use will parallelize via a browser, which is down in here. And this will actually create a new browser for each URL, fire that up, make a new page, go to that page, and close the browser. So every URL you see here gets a new browser instance. Now, a new browser instance is a fresh cache, it's a fresh cookie storage, fresh local storage. So it's like clean slate startup. That adds time. So when we do parallel pages here, we're probably going to see a bit of a slowdown. Just because, again, it's each page is getting a new fresh browser context. And especially for some, sites like Yahoo and Reddit, they're slow initially. So all this is running. Okay, so it took about 17 seconds to do that. Now, if I flip this over and use parallel pages, we'll talk about this for a little bit too. So parallel pages, you notice the difference is, while we had this while loop in both places, parallel pages will take one browser object and then it'll create a new page for each URL we're trying to visit. So this is effectively a way of multiplexing or parallelizing through one browser instance. So instead of firing up 3 browser processes, we're under the hood firing one browser process and running 3 sessions into it at a time. There's caveats to this. The first is that, these pages, I'm not making incognito for any of them. So they're all going to share cache, they're all going to share local storage, cookies, etc. So be very cautious about doing this. And if you're like logging into some site or something else, this could have consequences for that. But otherwise, if they're totally, benign pages, you're just getting data off of a website, that's totally fine. So good question. Does a fresh browser load with a fresh IP2? It can. So our usage-based fleet is a fleet of about 50 to 100 browsers, and those each have their own IP. If you go with something like dedicated, it's static. The reason that we did this is because a lot of content producers use static IPs as a way of filtering traffic. So that depends. If you want to use a proxy service, you definitely can. That's probably something we'll cover in another webinar, is using proxies and how to use them effectively. And especially with this rejection one too. If you're using a proxy, this rejection is awesome, because you don't want to funnel all these requests through your proxy. And most of them, not most, a lot of them will charge by bandwidth. And if you're loading images, style sheets, fonts, all through a proxy, it gets pretty costly pretty quick. So doing rejections with a proxy service is always like strong thumbs up for me. Again, obviously use cases are different. Some sites will need to load images to fire a load event or something like that. It's the internet. You can see any number of things. But for the most part, using a proxy for something like scraping is great, and you'll definitely want to block resources to that. So, but yeah, answer the question, fresh IP load with every browser, sometimes, but depends on the plan. Okay, so coming back to this, so up here was our browser parallelization, which took about 17 seconds. And then again, we saw node parallelization with pages. So it shaved off, half a second, just like not super, super awesome. But the funny thing is if we were to do this list again and again, and we kept this, page open, like let's say we had Yahoo in here 3 times, like each time it gets faster because the browser has already seen that page. There is a cache, all that. So this does get better over time. Once you've like hydrated the browser and have a cache of all the sites you've been to, really helps. The other thing this shows up to is with CPU and RAM usage again. So parallelizing through pages is a lot better CPU and resource usage than it is with via browsers. Again, the pitfalls of it, though, are you're going to see local storage, cookies are shared amongst those pages unless you create a new incognito context. So if you want to do that, you can just create a context. Then you do browser to create incognito context. So this is just like on your own computer, your own version of Chrome, creating an incognito context just means, hey, it's a new page, no shared cache, no shared cookies, local storage, etc. So you could do this if you wanted to keep it private between the pages. And while that works, it's not as fast, unfortunately, because they don't share a cache anymore. Once you create an incognito browser, doesn't matter what pages you go to, they're not going to share, cache of JavaScript and all that. It'll still save you CPU and memory usage time. So that's better overall, but it won't obviously have a huge performance increase. So yeah, take that as you may. That's just the way, things are with this. So again, whatever your use case is, it really will decide what you decide to do for doing that. But yeah, that's kind of how you can do that. All right, I'm going to put this back so it'll be in GitHub for everybody nice and clean. Okay. So we talked about rejections and doing that for proxy reasons and also for performance. We talked about parallelizing through pages versus through browsers and some of their caveats, which was great. The last one I want to share is kind of more like on the lines of a new fun feature. So this is what we're calling hybrid workflows. Hybrid workflows are something that requires a manual step. So for instance, I'm using GitHub. Now, my GitHub, I have second factor auth on it. So I log in, they text me a code, I paste that code in, and I'm logged in. That's really hard to automate, right? If you think about that, like you have to know somebody's username, you have to know their password, and you have to get this one-time code somehow from them. So if you're building like a payment provider or you're trying to get information from somebody's user account, like a good example is like a mortgage, right? Like mortgage applications, a lot of times will have you scrape bank information, which is against your bank's terms of service. So kind of sensitive. You don't want to be giving username and passwords out, obviously. So this is a way around that. So what this is going to do, there's two steps to this. The first one is I'm just going to create a new session in a new product we've been working on, a premium product. And I'm going to tell it some parameters. So firewalling is false. This just means that I can see pages that I haven't created. This is getting out there a little bit, but don't worry. And daemon is set to true. So that means once the session is done and I call browser.close, the browser process is actually going to stay open. And it's going to stay open underneath the session ID that I've assigned to it. So this setup will just open this page, go to GitHub and close. That's it. And then I'm going to do some magic after that. So buckle up. We're going to run setup. And we'll see if this works because this is bleeding edge. Cool. So that set everything up and it bailed. Nothing else. However, in this new product, there is a API to get sessions, kind of like what we had before, but it's a little different. So this one will tell you all the pages that browser are running and some other characteristics too. But there's also this new fun thing called a live URL. So this is something you can give somebody because it doesn't have the token associated with this instance. There's no API token. It's just a page ID and a browser ID, which are unique every time. So if I click on this link, what's actually happening is behind the scenes, the web browser that I just started is still running and it's streaming back its page here. It looks like I'm on GitHub, but if you can see from the URL bar, I'm not. I'm on this live URL. And this is why it's, kind of running a little slow just because it's sending back all these images and data. Now I can sign in as a user. Wait for it to load. Cool. So everything works like you normally would in a regular browser. You can type, do all that stuff. The demo gods are with me on this one. We'll get this thing working here. This is the problem. See, this is the thing that's hard to automate against, right? An authentication code. So like if you were to try to do this programmatically, you'd get this far and then you'd be like, oh no, this user has second factor auth enabled. How are we going to do this? So I'm just going to pop on my phone really quick and punch in this auth code. Cool. So now I'm logged in. I, as an end user, potentially am done. I can close this out and be finished. So we effectively logged in at this point. I've started a script and I've given this code to myself, but let's imagine you give it to the end user and they can log in for you and then log out. Now that I know that that end user is done, I can run this code below. And again, I'm not logging in here. I'm not doing anything else. I'm just reusing that same session I had made earlier. And I'm just going to take a screenshot of GitHub, just as an example. You could do whatever you wanted. You could do page content, whatever. But I'm just going to do a screenshot to kind of just prove the point that, hey, look, I'm logged in. So as you can see, like, you know, there I am. There's all the stuff from my auth session. I can delete this and run it again. And I'm still logged in. So this is a pretty powerful way of doing automation where like sensitive information is involved. You'll notice I'm not like saving a password anymore. There's no passwords being stored. There's no credit cards, no auth tokens, none of that. It's just set up in this session. The session stays around. And when we're done with it, we can delete it from a REST API call, or we can set a TTL. So for instance, if you need to do like a one-time scrape of patient information, let's say, you could set like an hour. Person has an hour to log into their site and be done. And then you can have some code after the fact that comes in and gets what it needs to, and then closes the session. So just to kind of prove this point again, you know, here's my screenshot. I'm still logged in. It hasn't changed. Now, I can delete the session, so I'm going to delete it. So now it's deleted. If I try to run that same script again, it's actually going to error because that session doesn't exist anymore. It's going to 404. And this is why I have this unhandled rejection back, because this, when Puppeteer tried to connect to that session ID, it says, hey, no, that session doesn't exist anymore. And even if I try to just do a regular connect just to see, it still doesn't like it because that's an invalid route. So this will run. This actually might take a second because GitHub, when you're not logged in, takes a few seconds to load. But again, just kind of trying to prove the point here that, you know, this is very like controlled. You have very strict controls on Premium, how this sort of hybrid workflow works. And again, there's parameters here that I didn't dive too deeply into, but these are just more, you know, levers that you have at your disposal to like, you know, firewall sessions from seeing each other or daemonizing the session. So anyways, but the old one, yeah, it's still the old one. Fortunately, GitHub timed out on me because it was taking too long. So just to kind of point that out. But anyways, this is the new stuff that we're working on. This is really powerful. I think it could potentially change how certain things operate on the web because nobody wants to share their username and password. And this gets around that. You don't have to share username and password. You don't have to do any of that. So yeah, so that's that. These are some cool web automation hacks. We did have some questions on our type form, so thanks for everybody for putting those out. The first one was more of a beginner question I want to talk about, which is just some basics of web scraping, what to do, you know, what are some things that you can do to make it better. Obviously, what we talked about here is great. You know, there's rejections you absolutely should look into, especially for proxying. Saves you a lot on bandwidth, goes faster, just in general, quote unquote. Parallelizing, if you're having to use headless Chrome, parallelizing with pages is often more performant, better resource usage than doing it with browsers. And again, that's just because Chrome can do resource allocation a lot better on its own. It doesn't have to fight with other instances of Chrome hogging resources. So those two are good. The other thing too that I would recommend is, you probably will need a proxy of some kind. There's a lot of IP banning people will do. There's also a stealth parameter. I didn't really have time to kind of go over that, but if you do @stealth here, this just makes headless Chrome look more like a regular user's Chrome browser. So very helpful to have that. A lot of times block ads and stealth will get you there 90% of the way there, So those two things are very helpful. The other one I've seen too that's kind of helpful is doing headless false. So there's some fingerprinting technologies out there that will use a canvas element and they'll draw on it certain primitives to tell what kind of browser you're using. It's pretty crazy. It's pretty intricate. To get around those, you do headless false, and that triggers the browser to render in a more userland type way. So yeah, those are the big ones I always recommend. Use our stealth parameter, use a proxy service, and then use headless false, for web browsers at least. Those three will tend to get you there. The other one that we had that was interesting, I thought question-wise, and I'll get to chat here in a minute, was, reusing sessions and making things go faster. So, this new session workflow is awesome for that. That's actually why we built it, was because we had a lot of people trying to do this and managing it themselves. And there's just a lot of ways that can go wrong. So for instance, this endpoint firewalling, we actually firewall at the protocol level. So there's really no way to get around this. So for instance, if you had this is set to true, and you had two scripts running at the same time, and they did console.log await browser.pages. Usually browser.pages shows all of the pages that instance is running. So it doesn't matter if it's your script that's making them or somebody else's, you'll see there, which is a security problem. When we have this firewall set to true, it makes it so you can't see theirs. You can only see the pages you've created. And that's because, again, behind the scenes, we do a lot of orchestration with Chrome's protocol to make sure that, hey, only this session can see these pages because we know that they've created them. It can't see everybody else's pages. So this is great for services or stuff out there where you're managing multiple scripts using the same sources. You can do that. They can even share the same browser instance and not see each other. And if you even want to go further than that, you can do and incognito is true. This will actually make every page run in an incognito context, whether or not you do that in code. So that just really reinforces that, pages can't see each other and they always are running incognito. And that way nobody can step on each other's toes and, ruin things. But this is still coming. I hate to show you all this and be like, look how great this is. You can't use it just yet because we're still developing it. But anyways, yeah. So yeah, good question. Is hybrid page rendering via canvas? Yes. So right now it's a canvas element that we inject in the page and we mirror all the click type events back and forth. There's still some caveats to that. Some web page GUIs don't always work. So things like the select element, I know, is a tough one. We're looking into workarounds on that. There's some interesting stuff with doing that tunneling protocol. I can't remember the name of it, that lets you remote VNC. That's what it is, doing a VNC instead, because then you'll get the native GUI. But there's all sorts of caveats to that approach too, because you want the page to be in focus. And if you've got two pages running and one says, hey, I want to be focused, then the other page stops running. So it's there's a lot of weird edge cases and sharp edges in this. So yeah. But yeah, that's the reason that we did Canvas, is because it's just easier. You don't have to worry about page focusing. But yeah, 1Password, since this is, different domain, 1Password won't see you're on this particular page. Copy and paste events are still something that we're working on as well, to see if we can get that working, because it would be great if they could just copy their password and that sort of a thing. So how do we deal with Cloudflare? Or how do you deal with Cloudflare? That's a good one. All of these bot detection algorithms work differently. And so dealing with one versus another is tricky sometimes. So the best way you can get around like recapture problems is using something like a residential proxy. A residential proxy is an actual user's computer running a proxy server. And that proxy provider will see your request and they'll have that user's computer funnel those requests for you. Oxylabs is one that we use and seem to like a lot. It does get pretty expensive to do it though, because it's very hard to, they pay their users that are running this proxy service. So it's costly because they're running a marketplace essentially. But that will allow you to look like a user because you're running their running your sessions through their IP address. So to Recapture, to Google, all those other providers, it looks like it's coming from that user's computer. Combine that with, you know, stealth parameters here, blocking ads, and, you know, headless is false. With all of those, you will look indistinguishable from a user's computer. So that's the big thing I would say is, yeah, use a residential proxy if you can afford it. If the budget allows, use a residential proxy because you'll be running requests from your user's computer. You want to make your code look as much as like a user computer. So Puppeteer even has like a slow-mo too, if I recall. Yeah. So slow-mo just means, hey, put like 100 millisecond gap in between click, types, all that. So again, mimicking more of like what a user looks like. Things like that can help. There are also Recapture services out there. I've never used one myself personally, so I can't really go too much into detail on like, you know, do they work? Are they better, et cetera? Those are kind of tough because they just send a screenshot to somebody. That person solves it. How, I don't know. And then your session goes forward from there. I think this is where like hybrid's going to be really interesting, to be honest, because this could, you know, you could send this to somebody that could solve it for you or your code. Once it's solved, then you can run your automation after the fact because you've gotten cookied or whatever. You're past the recapture point, and now you can run your automation on top of it. So stay tuned on this because this is, again, I think is really, really groundbreaking. It's going to make a huge difference. It'll get past things like recapturing, especially with some of these other strategies. When all those are combined together, you'll be good to go. Yeah, so I think that's it. This is great. Thank you for the questions. Appreciate it. Hope this is helpful for all of you. This will definitely be made public, this webinar. So if you need to watch it again, I went through pretty quickly and, you know, some of these topics may be known or unknown to you. So, you know, watch it again. This code I'll have in a public repo as well. So you can come back to it. Obviously you'll need a token. Well, this script for one won't work because this service isn't public yet, but it'll be at some point. But these other two definitely will. So you'll need a token to get these to work. So you can either sign up for the service or run the GitHub Docker image locally if you'd like, because that's entirely an option. But yeah, these are here for you to use. Hopefully that'll help. Yeah, I'm going to stop recording